Okay, welcome back. Today we're going to look at, fairly quickly here, angular velocity and arc length, sort of two concepts that go with radians, and terms that you'll see as you do questions, word problems in particular. Arc length, pretty straightforward, is the distance along the edge of the circle, and it's measured essentially in radians, or at least in the same units as radians are. We didn't really cover this last time, but from before, we know that 2 pi radians is 360 degrees, which means that if we found exactly 1 radian, or at least as close to 1 radian as we could in terms of degrees, we have 57.3. And so what that tells me is, when I look at a circle and I measure off an angle of 57.3 degrees, the distance along the edge of the circle here, this red part, so this red piece here, the length of it is going to be exactly 1 radius in length. Okay, so again, this is what a radian, this is sort of what radian implies, is that it's the number of radiuses, as yeah. So this length here and this length here are exactly the same. And so if we measured this length off, of course, from what we saw before, there would be basically another one here, and we'd end up with about 6.28 of them to make it all the way around the circle. But again, just to sort of clarify, that's how we're measuring things now. Instead of using the degrees really in our calculations, we're using this physical distance, this actual distance here, as we go around the circle. And we're measuring how many of those, or how far along that edge do we go to determine the size of an angle. Second term was angular velocity, and basically velocity and speed you've heard in physics. If you haven't, velocity is just speed with direction. And so in our cases, much like our angles being positive going this way and being negative going the other direction, our velocities will be the same. Velocities will be positive going counterclockwise and negative going clockwise. And velocity, of course, is distance over time, or speed is distance over time. So I'm just going to go through one word problem here dealing with those two concepts. The London Eye, I believe, is the largest Ferris wheel in the world. You can't quote me on that. And my diagram is wrong here. I meant to stretch this out. So the question tells me that the Ferris wheel is 135 meters tall, and asks me to determine a couple of distances along the edge of the Ferris wheel and some angular velocities. So key concepts here, the 135 and the 30 minutes are my two numbers. Determine the distance traveled in 10 minutes. In 10 minutes, I go a third of the way around the circle. And so 30 minutes is 2 pi radians. 10 minutes is going to be a third of that. And so the actual physical distance in meters will be calculated by taking 1/3 of this calculation. The 67.5 is just this value. 135 is my distance edge to edge. It's the height of the Ferris wheel, and so the radius is going to be half of that. So again, that's the radius. And as we said, the radius and radians are exactly the same length. 1 radian is 1 radius of length. And if you punch that in, you get something in the neighborhood of 141.4. The second question was if you go through 2 full rotations, and again, pretty straightforward stuff. 1 full rotation is 2 pi radians, so 2 rotations is 2 times that. That distance calculated the same way. Put in the 67.5 for the radians, the length of a radius. And we end up with 848.2. And of course, can conclude with, therefore, you will travel approximately 848.2 meters in a full ride. Could have been the same for the previous part, obviously, as well. Okay, so those are basically the arc lengths dealing with angular velocity. It's asking me to express in radians per second. Now remember that typically we include things like meters per second, kilometers per hour. And so in this case, radians per second implies that my final answer will be something or other radians per second. So I won't actually be plugging in the radius. Again, I messed this one up too. Let's just get rid of that one. We won't actually be plugging in the radius. If we wanted to calculate the number of meters per second we were traveling, then we would plug it in at that point. And so as we're going through this, 30 minutes is 1800 seconds. If I want radians per second, I do need to know the number of seconds for a given distance. So the distance I'm using is just the one that's in the question, sort of the standard 2 pi radians around the circle in 30 minutes, which of course is 2 pi radians in 1800 seconds, which is 2 pi over 1800 radians per second. And if we punch that in, we get something around this value here. If we wanted the actual velocity, actual speed that we're traveling 0.0035 radians per second. Each radian is 67.5 meters. So the actual velocity here. And if we did that calculation, we would find the actual speed that you're traveling on the edge of the circle. Okay, so approximately this many meters per second. And actually, just as a unit rule, if I'm canceling if I actually have my units in there, I should probably have them canceling. So 0.0035 radians per second times that many meters per radian leaves me that many meters per second. This is kind of one of the reasons we like radians, because the measurement makes perfect sense. It's this many radians per second. Whereas if we talked about degrees per second, the logic is there, but the math is kind of ugly. When I look at this, what I'm saying is, going back to my velocity or speed equation, velocity is distance over time, or again, speed is distance over time. I will flip-flop as I'm talking between velocity and speed. Recognize they are the same thing, except the velocity has us dealing with direction as well. And so as far as the numbers go, the numbers will always be the same, other than the fact that there may be a negative sign to indicate we're going the other way. So here what I've got is actually 360 degrees as a distance traveled, divided by the number of seconds. So logically, it doesn't seem to make as much sense. What it does tell me, though, is if I divide through, I get 0.2 degrees per second. And so you can sort of logically picture that. 0.2 degrees isn't very many, but every second, that's sort of how far we're going. But again, sort of just the idea that I'm measuring degrees as a distance is kind of an awkward thing. So radians, while you're not maybe as used to them, will become a nicer measure because it is actually a physical meters or kilometers or inches or centimeters sort of distance. And we can plot it on a graph because it is, again, the same measurement as any other values. And it also allows us to have numbers there that make sense when we're using them in some sort of a formula. If I say I'm traveling a certain 67.5 meters, that's pretty clear. If I say I'm traveling 3 degrees, that doesn't make as much sense. So for today, that's basically all we've got. Arc distance and angular velocity, just understanding what they mean and making use of them in some problems.